So in this video, we're going to learn how to convert between different base systems. So in this example, we want to convert 2120, and that's a number in base 3 to base 10. And remember, base 10 is our familiar Hindu Arabic system. And remember, we have the ones place, and then we have the tens place, and then we have the hundreds place, the thousands place, etc. Okay, so in the base 3 system, it's the same idea, but we use base 3. So we have 3 to the 0th power, 3 to the 1st power, 3 squared, 3 cubed, and so these are our place values. So I'm going to write the expanded form of 2120 base 3. And this is, so the 2 is in this place value. So what it really represents is 2 times 3 cubed. The 1, it corresponds to the 3 squared place value. So we have 1 times 3 squared. This 2 corresponds to this place value, 3 to the 1st power. So we have 2 times 3 to the 1st power. And finally, the 0 corresponds to the very rightmost place value. So we have 0 times 3 to the 0. So I'm just going to write this out. This is 2 times 27 plus 1 times 9 plus 6 plus 0. And that gives us, if we add it all together, that gives us the number 69. So 2120 in base 3 is equal to our familiar number 69. So let's do another example that's similar, but we want to convert 3BD2, that's a number in base 16, to base 10. So again, our familiar number system. So let me just remind you, base 16, our place values are given by, we have 16 to the 0th power, 16 to the 1st power, 16 squared, 16 cubed, etc. So these are our place values. And how do we write numbers from 0 to 15? Well, we would write those as using our normal numerals, 0, 1, 2, 3, etc., all the way to 9. But then once we get to 10, we don't want to confuse it with the 1 and the 0 we already have, so we use A, B, C, D, E, and F. Okay, so let's start with doing our expanded form. So 3BD2 base 16 is equal to, okay, so if we look at the 3, that is in this place. So that corresponds to 3 times 16 cubed. The B, so now remember, B is, what we would write is 11. So that's 11, and that's in this place value. So we have 11 times 16 squared. The D corresponds to this place. So in D, we know is 13. In 3, and then we said it's 16 to the 1st power. And then lastly, we have the 2 here, and the 2 is in this place value. So we have 2 times 16 to the 0th power. And just like simplifying this a little bit, we have 3 times 4096 plus 11 times 256 plus 196, or sorry, 208, plus 16 to the 0 is just 1, so this is 2. So if we add this all up, we get 15,314. Okay, so 3BD2 in base 16, also known as the hexadecimal system, is equal to 15,314. Okay, so in this example, we want to go in the other direction, and we want to convert 273 to base 5. So remember, 273, this is base 10, just our usual 273. We want to convert it to base 5. So remember base 5, my place values, on the right, we have 5 to the 0th power, then we have 5 to the 1st power, 5 squared, 5 cubed, 5 to the 4th, and we just keep going. Okay, these are the place values. And I'm also going to write down the values of these numbers. So 5 to the 0 is 1, and then we have 5, and then we have 25. 5 cubed is 125, and 5 to the 4th is 625, etc., and we could keep going. So I'm going to show you two methods for doing this. Method 1, I first ask myself, I first look at my number 273, and if I want to write it in base 5, I ask myself, which is the largest of these numbers that fits inside of 273, and that's 125, because 625 is too big. So I'm going to ask myself, how many copies of 125 can I fit inside of 273? So I'm going to divide. So 125 divided into 273. 125 does not go into 2 or 27, but it goes into 273 twice. 2 times 125 is 250, and then I subtract, and there's nothing to bring down, so this is my remainder. So then I go to the next number down, and I say, how many times does 25 go into the remainder of 23? And that's just 0, right? So, so I'm going to move down to this place value, and I'm going to say, how many times does 5 go into the remainder? It goes in 4 times. 4 times 5 is 20. Multiply, I subtract. So this is my remainder. And what does this procedure tell me? This tells me that 273 is equal to 2 times 125 plus 0 times 25 plus 4 times 5 plus 3 times 1. And I'm just going to write this in terms of powers of 5. So this is 2 times 5 cubed plus 0 times 5 squared, just so you can see the place values, plus 4 times 5 to the 1st power plus 3 times 5 to the... Now you can clearly see the place values and why I divided like that. So this tells me that 273 is equal to 2043 in base 5. So let me now show you a second method that's like a shortcut. And so in this method, what I'm going to do is I'm going to take the base, the desired base, and the number, and I'm going to divide. And I'm going to, so I'm first just going to do a simple division. So how many times does 5 go into 273? So 5 times 5 we know is 25. So I subtract and I bring down. How many times does 5 go into 23? 4 times. So 4 times 5 is 20. I subtract, and this is the remainder. So now what I'm going to do is I'm going to write the new quotient beneath the number, and I'm going to write the remainder out here. And then if 5 still goes into the new quotient, I divide again. So what I'm going to do is I'm going to divide again. I'm going to say, okay, let's divide 5 into 54. So I say 5 into 54. 5 goes into 5 once. I subtract. I bring down. How many times does 5 go into 4? 0 times. 5 times 0 is 0. I subtract. There's nothing to bring down. So I'm going to repeat what I did, and I'm going to write the quotient down together with the remainder. Okay, and then since 5 can still go into 10, I'm going to do the division again. So now I divide 5 into 10, and we know that just goes in twice. So I have 5 times 2 is 10. I multiply, I subtract. There's nothing to bring down. There's no remainder. So the new quotient is 2. And the remainder is 0. So here's the key to the shortcut. And that's that the bottom number together with the remainders gives us the base 5 number. So you move in this direction. So the base 5 number is 2043. And then I'm going to write a 5 here for base 5. And this is equal to our usual 273. And notice how that's the same answer we got before. Now this question is similar to the previous question. We want to convert 691, so that's base 10. And we want to convert that to base 16. So if you recall, base 16, we had 16 to the 0th. These are our, correspond to our place values, etc. And I just want to write the actual values of those numbers for you. So 16 to the 0th power is 1, and then we have 16. 16 squared is 256. And 16 cubed is 4096, etc. And we can keep going to the higher place values. So let's use method 1. So I look at the number 691 and I say which is the largest of the place values that goes into 691, and it's 256. So I'm going to divide 256 into 691, and it appears that goes in, I think, twice. So 2 times 256 is 512. So I'm going to subtract, and I get 179, and that's less than 256, so we're good. That's my remainder. So I take the remainder, and now I'm going to see, well, how many groups of 16 go into this remainder? So I'm going to divide this guy by 16. So 179. So 16 goes into 17 once. So I subtract and I bring down. 16 goes into 19 once. I subtract. And my remainder I get is 3. And the only remaining, so 1 obviously goes into 3 times. So we're almost done. So now this tells me, the work that I did over here shows me that 691 is equal to 2 times 256 plus, and then we had 11 times 16 plus, and then we have 3 times 1, and I'm just going to rewrite that for you with the base 16 numbers. So this is 16 squared plus 11 times 16 to the first power plus 3 times 16 raised to the 0th power. And now you can see how those place values fit in. And so 691 is equal to 2. And then remember 11, we don't want to confuse with 1, 1. So the 11, I'm going to write using, so remember in base 16, we had 1, 2, we go all the way through 9, and then we use A, B, C, D, E, F. So 9, 10, 11 is, B is 11. So I'm going to use a B here. So we have B, and then here we have 3. And I write 16 down here, so I know that I'm in base 16. So 691 is equal to 2B3 in base 16, the hexadecimal system.